The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
It's so busy.
So we had some amazing pizza, extraordinary pizza for lunch today. We were starving when we got here because we flew into Miami. All I had in my stomach was some coffee and some Delta
Peanuts.
cookies.
Yeah,
from
that was
the
pretty
Delta
good
flight.
for me. Plain food.
Yeah. So
coffee and almonds.
we were hungry, and we went to a place called Mr. Extraordinary. So
Mr. Extraordinary Pizza.
Mr. Extraordinary Pizza.
Yes. It's actually in Aventura, Florida. Was where we're actually
where we're at right now. We're in Miami.
There's other ways of saying that.
And Aventura is north of Miami, south of Fort Lauderdale.
Right. And, we come to Miami, the pizza is the last thing I expected to have for lunch.
Yes.
I agree.
But I tell you what, I was glad we got it because this was very, very good pizza.
I even said, I can't believe I'm in Miami eating pizza.
Yeah. But it was so good.
But it
So
was
we each
so
got
good.
our own, and it's almost like I was so hungry. To me, it was like a personal pizza.
Well,
It was like a
wasn't-
13-inch
yeah,
pizza.
It's a personal pizza.
Yeah, so I
Every pizza is personal if you're committed enough.
like that. I like that.
But yeah, I had the meat
absolutely
lovers.
true.
Meat
You had the meat
lovers had
lovers.
the ham, the sausage.
That was good.
The pepperoni. And that sauce, that olive oil that they brought us, that spicy,
The spicy,
Oh, yeah, that was
olive,
good.
virgin
Yeah,
olive
that was
oil.
amazing.
Oh, that was awesome.
I had a pizza called the Maria, which had prosciutto. It had shaved Parmesan cheese,
Yeah.
right?
And
Arugula. It was really good, and just so you guys know what kind of pizza it is, it's kind of, I wouldn't say thin crust. It's somewhere between,
It was pretty thin.
It was
Yeah,
pretty
pretty
thin.
thin
yeah.
crust.
I would
It
say
was-
thin crust.
but
Any thinner.
barely any flop in the pizza.
No,
it was great.
it was firm.
And now I sound like Dave Portnoy over here, rating pizza, but
Are we allowed to mention him?
yes,
Okay.
absolutely.
I don't want him to shut us down.
He rates pizza all over the place. Dave's the man. So, very little flop on the pizza and nice undercarriage. It was delicious.
and
Roland, what
crispy.
did you get?
I got the prosciutto. And I say
Okay.
it, prosciutto.
Prosciutto.
It doesn't matter how you say it.
Yeah.
Depends what part of Italy you're from.
But yours had prosciutto on it
But
as well?
Prosciutto on it.
Just say
It
ham.
had cheese on it. Look almost like a.
Most
like
pizzas
a-
have cheese on it.
No. But it wasn't just regular cheese. It was like.
You
What kind of
had
cheese?
fresh mozzarella. is what you had.
Mozzarella.
It was-
That's
but
what
it was-
mozzarella.
it
I
wasn't
don't know.
the shredded-
I can't remember it, but I can say
It wasn't the shredded mozzarella. It was the fresh kind.
No. It's fresh.
It was
mozzarella.
real stuff. Right?
Yeah. It
And
was good.
I just got the boring pepperoni.
No, it was actually, pepperoni sometimes is just the perfect mix
Pizza.
of meat and
But
cheese.
the good thing,
If it's done right.
That's
the
how I
good thing
judge.
about getting 4 different pizzas, we were able to share each
Right.
one. So that was awesome.
Now, I judge pizza places on the pepperoni pizza. I judge Italian restaurants on their chicken parm. So that's what I do. Oh.
Yeah, so what about that olive oil? That spicy,
Oh, that spicy
That was
virgin
some-
olive
little
oil.
zip,
Oh, that
yeah.
was good.
Yeah.
That
Had the
was
red
good.
pepper flakes there. It's some Parmesan.
Yeah.
I'm afraid of spicy things, so I had to put it on a knife and taste it, and it was just the right bite. It wasn't overcoming, so it was awesome.
Did we say the name of the place yet?
Yeah,
I think you need to say it again.
To be exact, it's
Mr.
Mr. 01 Extraordinary.
Yeah, and I think the intention
Pizza.
there is Mr. One Extraordinary Pizza. And it's in, we mentioned the place, Aventura, Florida,
Yeah, yeah.
which we happen to be here for the 2023 Diamond Contractor Conference.
Yes.
And there's 2 of these. One's on the East Coast, and let's call it Miami, even though
Yes.
we're halfway between Miami and Fort Lauderdale. And the second one is going to be in a few weeks for the West Coast, and that's going to be in Phoenix.
Okay.
Yeah, so we got a bunch of vendors here. All of our diamond contractors are here. They're walking around, checking out different. So we set up a podcast, the METUS Tech Show. We're here live. We'll be releasing this. So we're not actually doing it live, but we'll be releasing the episode soon.
We're recording it live.
Yeah.
Pretty much, but you can tell by the background.
Yeah, it's pretty noisy.
It's pretty busy here.
And
Pretty busy.
now we've done this. This is our 3rd time recording it live at an event like this, and this probably is the noisiest one that we've had
Yes.
so far. So I'm hoping this comes out okay and people can hear it and it's not annoying. But Time will
Because
tell.
if it doesn't come out, nobody will ever hear it.
That's
so,
true.
yeah.
So I just wasted that whole sentence.
That makes
there.
sense, Roland.
Good point, Roland.
Good
Wait and
point.
forethought. That's your strength.
So-
That's your
Every once in a
superpower.
while, I have a moment of intelligence.
So, Steve, what's going to be the topic on this one?
So I thought this was going to be an important topic, compressor diagnosis, right? So we get a lot of compressors back to the factory with nothing wrong with them. Nothing wrong with the compressors. They test
Wow.
out just fine. Now, why is that happening? Why is that happening, Warren?
Because most technicians don't know how to properly troubleshoot or diagnose the compressor.
Well, they probably do. Most of them probably do, but what's happening is they may be diagnosing that compressor when there's cold stacked refrigerant in the compressor, and that acts as a conductor.
Yes.
So we can get false positives when we're diagnosing that compressor. We either when we're diagnosing with a multimeter or a megometer. So let's talk about some reasons for compressor failures, right? And the first one, the big one, I think we need to talk about is moisture.
Moisture.
Right?
And you know something when it comes. Well, every time I discuss moisture in our training, is that how in the world does moisture get inside the system?
If you do a proper evacuation,
Absolutely.
and you do it the right way, you can guarantee one thing: there is no moisture in the system,
Right.
and there's no leak in the system. Period.
I agree.
Right. So that's what but you have to do it right, and that's a different podcast. I think we've already done triple evacuation. So.
Yep.
But go back and listen to that one if you haven't heard it. But that's an important one. So moisture is the one. Actually, there's a bunch of these that can be prevented, but moisture is one that can definitely be prevented from day one, and anytime a system is opened by performing a proper evacuation.
Yeah, moisture and oil do not mix.
No.
Neither does with refrigerant.
Right, and now we got 410A, and,
Yes.
and who knows what's coming down the road, but 410A is less forgiving than R22 was.
Very
It's more
much.
so the oil that comes with it.
Right.
But,
so
you know,
ester oil, POE oil,
Yeah.
whatever you want to
More
call it. It's not the days of mineral oil anymore.
Right.
We're introducing these new oils in the field, and they have an affinity for water. They want to pull that moisture in. As soon as any moisture in the system, they pull that right in.
And they hydrolyze faster, much faster than mineral oil. And the other thing, too, is back in the old days, it was a little bit different because we had filter dryers. And why do we have filter dryers in there? Why do you need a filter dryer if you do a proper triple evacuation?
Yes.
You don't need filter
it.
dryers.
But it was just the way that people thought back in there
Yes.
because we got away with
Listen,
it.
yeah.
Nowadays, you
And-
can't do it.
And to add to that, Roland, back in the old days, as you mentioned, I mean, the triple evacuation was in the books since the first day, the first
Yeah,
refrigeration
absolutely. And look,
cycle was invented.
And let's call it what it is. Our industry back in the day, and I think three of us are definitely old timers, But back in the day, we had a lot of bad habits that we passed down to other people that we've learned from old timers when we were young. And that's just a bad habit. There's no need to put a filter dryer in the system if you evacuate it properly.
Right, but the other thing, too, is that those bad habits that you're saying, the other thing, too, is that, R22 was capable of holding more moisture without hydrolyzing it
Correct.
than 410A.
Correct.
So go with our bad habits. Also, the specifics of that refrigerant was much different than they are now.
Right, but we had those bad habits, and we moved to refrigerants that aren't as tolerant, and it just exacerbates the problem.
I'll bring something. So every once in a while, do you guys say beer can cold in class?
Yeah.
You go beer can cold, and the younger generation have no idea what we're
Thank
talking
God.
about.
Thank
They
God
have no
they
idea
don't.
what we're talking about. Exactly. Thank God they don't know. And the older generation, beer can cold. I know what that is. But the other thing, too, let's just go back with the triple evacuation. What's the reason for a triple evacuation? The main reason, and I have I've noticed more and more students answer the question right. It's because of the fact we break that vacuum because we can freeze water.
Yes,
And
sublimation.
once we break that vacuum, come back to 0 psi on the gauge, that water melts.
Yes.
Now we can boil that water out. And I've noticed that more and more people know that than 10, 15 years ago.
Good. That's a good thing.
it's
So
a
the
great
word's
thing,
getting out
great
there.
thing, great thing.
Yeah, and that process is called sublimation, when you can take moisture as a vapor, you skip the liquid stage, and it goes to a solid. And if you just open that up and you finish a single evacuation, the 500, 200 microns
Whatever.
even, that moisture's still there.
It's going to melt,
And
turn into water.
yeah.
It's in your system.
So it's not good.
But acid is moisture, refrigerant, and oil. That's where it collects in the oil. It's acid.
Yeah. Another problem that we see with compressors a lot lately, and it's really surprising, is foreign debris in the compressor. We've found compressors that we've taken back that, they've been condemned, and we bring them back and we find they're shorted. We find sheetrock dust, we find copper
silica.
shavings, pebbles.
Yes.
Little ground like sand in these things
The
here.
beach.
And some of our guys have been on sites where buildings have been roughed in, the line sets sticking through the roof, exposed, open, with maybe a little piece of electrical tape over the end.
Right.
That we also had, a podcast on piping principles, best practices. Go back and listen to that. But those pipes, those lines have to be dry and tight the whole time until you connect them. We cannot leave those open to the atmosphere, especially when it's going to get rained on and snow. And we've seen people drag them across the ground and get dirt and
And not
sand
only
in them.
that, when you're cutting and deburring the copper, all those filings are going inside the pipe and not being removed.
Yeah. If you're running refrigerant pipe, it has to be ACR.
Yes.
Which means it comes cleaned inside and capped on both ends. And if you have to cut that, it has to be capped if you're not going to make the final connections.
Exactly.
So please do that.
Yeah, and you can get from just debris, we're talking copper filings, any type of brass filings that are in the system, they can actually wreak havoc with the fusite terminals inside the compressor.
Yes.
Right inside of that compressor, that can build up across the terminals and cause a catastrophic short inside that compressor. We're seeing a lot of that.
And imagine those copper filings falling in between the rotor and the stator and the motor.
And that's not good either. And it's causing undue wear.
Yes.
On the on the mechanical part of the compressor. There's a bunch of things that can go wrong, but there's only two things you want to see in that refrigerant pipe ever in that system, and that's the refrigerant and the oil that's part of that refrigerant. Nothing else belongs there. Keep it tight, keep it clean. Don't open the copper pipe until you're ready to make the final connection, and if you have to open it temporarily, seal it.
Exactly.
Don't run it through a wall, or through a floor or up a wall, open. Please.
Well, and just to reiterate on that a little bit more. And when you put your copper away back in your van for like a week or two, or however long it sits there,
seal it.
Seal it.
Yes.
Be aware that anything in that van, if that copper is open, can make it inside there.
And listen, can I just say that electrical tape is not a proper way to seal the end of the ACR?
And actually, no tape.
No tape.
Period.
That's right. Yeah.
Because there's not a tape made on Earth that is designed to stick always.
Right.
Because of temperature changes, the glue gives out.
So what are you saying? Save the caps?
Caps, or
Yeah.
even
Just save the
brace
caps.
it.
Brace it.
Even brace it.
Flatten it.
Smash it together with a hammer.
Flatten it and braise it is
Yep.
the best thing.
Fold it over a pair of
nothing
channel
will get in it then.
Absolutely.
Good.
So talking of oil, let's go to the next one. Lack of oil return.
Lack of oil. So what causes lack of oil return to? Because the only place in the system that needs to see oil is the compressor. Right.
Absolutely.
So what prevents oil from going to the compressor, or what prevents it from staying in the compressor?
Exceeded line lengths.
Yeah.
Right? If we over exceed line lengths, if we don't follow the proper procedures in the installation manual, we cause traps.
Right. Yeah.
And we can inadvertently cause traps in the system, not even knowing.
Prevent the oil from returning.
Yeah.
Absolutely.
You know what else is a thing is improper line diameters. If you get the wrong
yeah,
pipe
right.
size
Absolutely.
and you don't get that velocity,
It affects the velocity.
Yeah.
Absolutely.
And I think the most important one is probably vertical separation of
yes,
equipment.
Yes.
took the words right out of my mouth.
Yeah, so that, we're in reference from where your compressor is, where your outdoor unit is, to the farthest indoor unit, or how far the branch controller is from the outdoor unit. As far as vertical separation, that could definitely affect oil return in our
because
systems.
Which if the condenser is down and the evaporator is up high, you got to push that liquid column up, and you've got to push that oil up so it can come and return back through the section.
Right.
Or the opposite, having a condenser on the roof and the evaporator below the condenser.
Yes.
You're relying on velocity to
bring it
lift
back
that
up.
oil back up, because we don't put in oil traps. We do not do that with Mitsubishi equipment. Okay.
It's designed and engineered to get its oil back by following the pipelines.
Excellent. Where would you get that information?
Installation manual at mylinkdrive.com.
And the installation manual does come with a piece of equipment.
Now, when we're talking residential, we can kind of follow the pipe length restrictions in the installation manual fairly easily. When it goes to VRF and City Multi, now we're talking Diamond System Builder software.
The only way to do it.
That's where we talk about it almost in every podcast.
Yes.
Diamond System Builder is free software available on mylinkdrive.com. It's going to take care of keeping track of your pipe lengths. It's going to keep track of your 90s, your elbows in the system, and your vertical separation. Again, that's really
It's not
important.
going to let you make a mistake.
Yeah,
Right.
and listen, Diamond System Builder or DSB is not just for the large commercial jobs. You can use it on a one-to-one,
Yes.
or a smart multi, or
Absolutely.
a
Small
multi-zone.
residential.
It's for everything.
Yep.
All right, so we've covered lack of oil, but how does a lack of refrigerant affect the compressor?
So lack of refrigerant is actually going to increase your compressor temperature, number one.
Yes. Right.
So that's going to, hopefully the system's going to shut down before it gets to that point where, you're trying to think of the word here, where you're flashing off oil.
Right, because it actually it breaks it down.
It breaks it down.
And,
exactly.
and there's not enough cool vapor coming
Yes.
back to cool the compressor.
Well, and the other thing too is that refrigerant coming back assists in lifting that oil out of that bottom up the sump into the cylinder. And if you look at the dynamics of inside a scroll and a rotary, is that oil is the final seal between the high side and the low side, that fine, thin cover of oil. So refrigerant doesn't come back. Refrigerant doesn't lift that oil. So you need refrigerant. I mean, I'm assuming that's an extreme low undercharge scenario, but that refrigerant is responsible for moving that oil for lubrication.
Okay, so that's a lack of refrigerant. How does an excess of refrigerant damage a compressor?
Well, it's a vapor pump. At the end of the day, it's a vapor pump. It cannot pump liquid, right?
Nope.
We cannot pull liquid back out. Roland's ordering a pizza right now from Mr.
He did not have enough.
It's Tony's pizza, yeah.
I want some cheese. I want some cheese with pepperoni on it.
But what is going to cause flooding? Yeah, prosciutto.
Poor charging practices.
Yeah,
you
so
can overcharge a system.
Overcharge,
Dirty filters can
dirty
cause
filters, dirty
Yeah.
coils.
because you're not evaporating.
You throw your gauges on and you see a low back pressure. You go, oh, it must be low on refrigerant. You're going to put it in there.
Airflow.
I know, but
Yes.
I'm just saying
Yep.
there's some of the mistakes that we make
Right.
in
And
the
that's
field
what people
out
have to check.
Restrictions. Because of trash.
Yeah, and a restriction. Now, restrictions to me, it used to get. For me, when I first started and even still, a restriction, and then that somebody else was there before you, and then they added refrigerant. Now you got a restriction with an overcharge. And talk about trying to figure out what's going on.
Absolutely.
Sometimes you just got to start over and just. I got to put the right amount of refrigerant in here, and that always drove me crazy when somebody else did it wrong. Now you got two problems, which makes it much harder to find the original problem.
And regarding overcharge, I'll never forget, because you just brought that story to my mind, that event. I was dealing with a technician on the field, and he was on the phone, and he goes, Juan, I have a sight glass on this line, and I've been putting, the system tells me it holds 7 pounds, but I've added 9 pounds, and I'm still seeing bubbles on the line, on the sight glass. And I'm telling him, well, where is the LED? And there's a pause. I said, well, it's on the inside.
The light bulb just went on.
Yeah, I'm not allowed to repeat the word that he used after he realized what he was doing.
Yeah, I see where you're going.
So for any Mitsubishi system, no filter dryers, no sight glasses. Sight glasses, actually, I'm going to go one step beyond and say I don't think you need those on any air conditioning or heat pump
Absolutely
system.
not
anymore.
No sight glasses. That's not the way we do it.
But that was really confined to refrigeration. I mean, you saw it in air conditioning, but
the guys put it in air conditioning because they're refrigeration guys. That's what they knew, so they put it in. Didn't really need it.
Yeah.
But let's move on. So I think
So
that's
now
pretty much.
we need to talk about one more before that one. Incorrect incoming voltage.
Well, I was going to say we can switch from mechanical to electrical.
Okay, I shall let you speak then.
Yes, don't interrupt me again. You're fired.
Adios.
Okay, so anyway, let's segue from mechanical to now electrically what can damage a compressor. Besides lightning. Obviously, lightning, there's nothing you can do about that. It happens. It can fry everything. So let's leave lightning out of it.
Low voltage. The system is rated at 208, 230, plus or minus 10%. So there's your range, typically 187 to 253.
Yeah.
So anything below that or anything above that, it's going to be a problem.
Yeah, because the low voltage, low incoming power, the compressor is going to try to draw more current in there, so it's going to overheat. That's a problem. Which
Yes.
and the same thing with overcurrent. This is why it's 208, 230, if that's what it says on the name tag, and it's plus or
Yes.
minus 10%. So what do we do if you're in one of those areas? And I've seen these areas, they can be a rural place, or they can be right in the middle of a city someplace, just at the end of a line. What do you do if the voltage is not steady and you can't guarantee that you're not going to have that low drop or that excess of voltage? What can we do?
I've seen the application of buck and boost transformers that level out that fluctuations. I've seen as high as 265 volts in a residential area.
And to just comment on that, in Florida, we have, and I've worked in, 8, 9 different states in this country, and I've never seen high voltage like I see in Florida. Anywhere in the country.
Carolina's is pretty up there. I was out at a training center in I believe it was North Carolina, and speaking to someone, and I noticed they had buck boost transformers on all their training equipment.
Right.
And I was like, why on the training equipment? It's great to show that that's, he's like, well, our voltage coming off the street is in the high 240s. I was, really? Interesting. So it's common for them to sell a buck boost transformer right out of the gate.
Up in New England, but in Florida, all the contractors, they put buck boosters in areas like the villages and that on every single unit. It's automatic. It's just automatic.
Yeah, but that the incoming power, and that it be a steady power, is even more important now with all the electronics.
Yes.
It's not just the compressors,
Absolutely.
the electronics. They like steady incoming voltage. So if you're in an area that varies from that, you need some type of conditioner on that line.
And let's not forget about the ground wire, because you may have proper voltage, but if you don't have the proper grounding because of the electronics, you're going to have problems electrically.
I remember this was one of the weirdest things I've ever done. My aunt had a house with a hot surface ignition gas furnace, and she was going through igniters like crazy. And I would check the power, and she had the right power check. So one day I sat there and I waited, and I had my meter at the, and I cycled it through a couple of startups, and I saw my analog meter go from 120
Jump
to 240, but it jumped. To come to find out, it was a bad ground. So because it couldn't go back through the bad neutral, it couldn't go back through the neutral. For momentarily, I had we were seeing both lines of power coming in, and if it happened when the igniter is glowing, then boom. So
and every time I teach the electrical system, I tell the students, the ground wire, as far as I'm concerned, is the most important wire in the whole system.
Yeah, especially with MNet, and we're not going to go into that. We just had an MNet episode. But,
And just to back up on something I said a few minutes ago, when I said aunt, for some of you out there, that's aunt. Married to your uncle. Married to your uncle.
There goes that accent.
Answer something I step on.
all right, so let's talk about some things that contractors will find with a compressor electrically when they're diagnosing the compressor. First one I want to talk about is shorted windings. So we're talking about winding to winding is shorted out internally. So what is a contractor going to see when he puts his meter across two terminals where the windings are shorted?
Because, inverter compressors will know that they are three-phase compressors. So when you do a resistance test, you want to see 3 equal readings.
Right.
So when one of those windings are shorted, one of those readings is not going to be equal compared to the other two. So that's a sign of a shorted compressor.
Right. And I always get this question in class from contractors is, well, how do I know what the reading's supposed to be? Just like anything else, you got to look at the service manual.
Absolutely.
All of that is in the service manual.
Right.
Where can I find that service manual? I feel like we don't tell people where to find the service manual.
MyLakeDrive.com.
Yeah, but here's another thing, and this has happened in class. I was going over a scenario, larger the compressors, low the ohm readings are, because they're bigger windings. So I was going over an ohm reading, and I said, I'm looking for relatively, within an ohm, if that. And the student looked at me and said, well, this says anywhere from 33 to like 67. I said, no. you're going to have different ohm readings at different temperatures.
Right.
And that's what that was referring
Yes.
to. I'm
Yes.
still looking for balance.
And that goes for
Right.
solenoid valves.
It goes
that-
everything.
Solenoids. It goes for
LEDs,
Any winding,
LEDs,
everything.
reversing valve coils.
It's just like the voltage. Listen, it's an inverter compressor. Treat it like a three-phase motor.
It is a three-phase
It is a
motor.
three-phase motor.
Right.
So you need balanced voltage and you need balanced resistance. From U to V should be the same resistance as V to W and W to U. Those should all be equal resistance. If you got one that's way off, and I would say I think it's more than an ohm. I think it's if you got it way off, that compressor's no good.
Right. So, some of those ohm readings are, once again, unit specific, but there's some units I've done where the ohm reading was 0.9, 0.9,
Yeah.
0.9.
Yeah.
I've
Our
looked at other ones
compressors-
and they were 1.3, 1.3, 1.3.
Our compressors are very
they
low
are
resistance.
low numbers.
Yes.
But now, okay, let's just take a look at one that's 1 ohm, 1 ohm, 1 ohm, and let's say one of them is at 0.8. Now that becomes 20%. If you start doing percentages.
Yeah.
So you got to take that into consideration.
And there's something else I want you to consider too. So when we had our DSG conference a couple of months ago, a couple of our guys did a class on inverter compressor analysis. And this, I never would have thought of this if I hadn't said in there. So thank you, Sean Taus, for putting that class together. But he was showing a video how they took a meter, a digital meter, and they put the leads together, it's set to resistance reading, to ohms. They put the leads together, and it was reading like, I'm going to make that up because I don't remember what it was. It was like 1.1 ohms with the leads touching each other. Then he took his reading, and it was 2.1. And the reading was supposed to be between 3 and 5, let's just say, right? Well, that ghost resistance, I'm going to call it, when you put the leads together, you have to add that to the value
actual
that you're
reading.
measuring. And when he did that, it was right within the specs of what it should have been, according
Wow,
to the
that's
manual.
awesome.
So something to consider.
Yes.
I'm so used to putting the leads together for resistance and getting zero. Right?
Or hearing the continuity beep.
Right, but if you have a reading, whatever you actually read, you have to add that
Got
to
it,
it.
too.
So,
Right.
That's good. That's
Yeah.
good. So
But
we've
nevertheless,
had,
that should be still checked. And then the other thing, I'll just comment on continuity reading. I get guys all the time that are doing ohm readings with their continuity.
It's not the same.
With their audible. No,
it's not the same.
Because you'll come up with two different readings.
Yes.
That's just for continuity. Hence the name continuity beep.
let's talk about megging a compressor, because I just heard a story recently how a guy was megging a compressor from one winding to another winding. Mm-hmm. That's not cool.
No.
All right, so Steve,
Yeah.
you've been awfully quiet over there. You awake?
Yes.
Oh yeah,
The
yeah.
pizza-
No, I'm
pizza
just
hangover?
Hi,
I'm
Steve.
listening to the brains here and learning a thing or two.
That's why you fell asleep. You're listening to us. All right, Steve. So walk us through megging a compressor.
So megging a compressor, and this, you're going to have a good. There are a ton of different megometers on the market. There are some types that are non-adjustable, so there's no dial on it, and it just has some lights that light up a certain
Right.
resistance. And basically, they have a grounding clamp, almost like a large alligator clamp, where you can find a good spot without paint on it.
Right.
All right, on the compressor, where you can grab a solid piece of copper,
Bare copper.
bare copper, and you have a test lead where there's a test button on this test lead. Now, you don't want to put that thing on your tongue because you're going to get lit up.
Ouch.
All right, but basically, what you're doing is you're sending voltage. Very low amperage, by the way. It's just high voltage, anywhere from, and usually there's two settings, 500 volts and 1,000 volts. And you're taking that red probe and holding the test button on that probe and putting it on each terminal and checking the resistance to ground through the winding. You're checking the integrity of the varnish on the on those
insulation.
windings, the insulation on those windings. And our compressor should meg out at above 1 million ohms.
Right. And Steve, how important is the temperature of that compressor when you're
So
megging it?
important. So let's talk about residential equipment. Residential equipment, Mitsubishi heat pump M series, you have to be very careful. When we test our equipment at the factory, we want to present that equipment to the field at its highest SEER, right? At its highest COP. at its highest efficiency. Most of the time, our crankcase heater or preheat control.
Yeah.
Because when we say crankcase heater, everybody thinks, well, it's a strap-type
heater around the compressor.
heater around the compressor, which, by the way, we will be going back to in our newer generation, and we'll talk about that later. But our residential equipment, we don't activate the preheat control because that condenser rolling can be going down in Florida. Do you
Absolutely.
care about
I don't need it. I don't care about it. No.
No, but we need it in the Northeast. Juan, you're up in central United States.
Yes.
Cold climate.
Absolutely.
You need that preheat control. So on the M series residential units, we're actually cutting a jumper on the outdoor unit to activate that.
Yes.
When needed. What that does, it warms that compressor up. It's not a quick thing. It takes 12 hours to warm that compressor up. And what we're doing is we're boiling refrigerant out of the compressor. We're boiling that refrigerant off, and we're getting that compressor at a temperature where, number one, it can start up and not pump liquid.
Right.
It's important. But number two, if you're diagnosing that compressor with a megometer, or you're just checking resistance across the windings. Let's just talk basic multimeter. If you're checking resistance across those windings, that compressor has to be at a certain temperature so that you're getting an accurate reading. Right? Now, on our hyperheat units, crankcase heater or preheat control's already active. With our VRF City Multi, it's already active, so you don't have to energize
And that's what I was
anything.
going to say, Steve. You set up a cutting a jumper. Even on the M series, you have to be careful. I would look at the service manual because some models that feature is already active, even on the M series.
Model specific.
Right, but the bottom line is that compressor has to warm up before you start it, before you meg it out, before you take an ohm reading of those windings or resistance readings.
Yes.
Otherwise, you're likely to condemn a perfectly good compressor.
Before you even start it up.
Yep.
Correct.
Again, we get a lot of compressors back to the factory, like I said earlier, that have nothing wrong with them, and it's because of that. And we cut our compressors open. We have QA team that will cut them open and check and see what damaged that compressor.
And they're fully tested.
And so we'll test them, and a lot of them there is nothing wrong. They were just testing with us, getting a false positive on that compressor.
So,
and then,
as far as
go
the
ahead.
windings, what have we covered so far? We've covered shorted windings,
Shorts to
voltage.
ground.
We need to talk about a short to ground?
Yep, we talked about short to ground.
All right, and we talked about it. We've never talked about an open winding.
I don't
No,
think so.
we haven't talked about open
All right,
windings.
so what can cause an open winding?
Well,
Well,
I've
you
seen
go right back to the acid burnout. You know, you're going to get that oil's going to be acidic. That oil's going to drip over the winding. The winding don't touch each other, even though they look it. It's got that lacquer coating on it, shellac lacquer coating on it. You start burning off that lacquer, boom. You're taking shortcuts with that electricity, overheating. You're arcing. If you're arcing within the canister, you're now phosgene gas. You're burning refrigerant.
And if you get some of
Carbon.
that, if you get some of that debris in there in those windings, and it causes an arc to the shell of the compressor, the windings could just break down.
Breaking.
And I've actually have seen open windings also in a slugging condition for some reason.
On a
Due to-
slugging condition?
On a slugging condition.
Interesting.
The crankcase gets full of liquid, and it does something to the windings that I think, because it eats through the varnish or the insulation, and then it causes that arcing.
Well, yeah, I can see that refrigerant coming back and flashing off and changing temperature.
Yes.
Causing that winding to expand. Expand could break off that lacquer, sure.
Yeah. Well, and something I want to kind of point out is like we said earlier, our compressors are inverter driven. So can we have a damaged compressor because of the inverter?
Sure.
Yeah,
I think so.
absolutely. Right. So the power board is putting out imbalanced voltage. Mm-hmm. Could damage a compressor.
Absolutely.
So I can't stress this enough in class when I talk to contractors. I said, look, when you condemn a compressor, are you looking at other components in the system?
Did you
what
have
do you mean?
balanced voltage?
Yes.
You know,
And here's another thing, too. Every one of my class, balanced voltage, 10%. Not always.
No.
Once
Right.
again, unit specific. Sometimes some of them are only 4%. Balanced voltage is only 4%.
And anytime
just
I've
be aware of that.
anytime I've taken a voltage reading, it's pretty darn close.
Oh,
Yes.
yeah.
I mean,
Nothing like-
I'd say if it's more than 1 or 2%, you got a problem.
Yeah.
But they're pretty close.
But typically about the integrity of the windings, typically the resistance test gives it to you.
Yeah.
By having
Right,
equal
right,
resistance. That tells you
Right.
about the integrity of the windings.
But the point I was making is, whether you're diagnosing you diagnose a bad compressor, do you stop there? No, you got to check and make sure that your power
Absolutely.
board is putting out
Absolutely.
balanced voltage. And at the same time, if you have a bad power board, do I just go
Yes.
out, order a new power board, and pop it in?
No. Right.
Well,
You
I got to
gotta
check
check
my
the
compressor,
compressor.
right?
Yes.
So it's got to check both things. Don't become a parts changer.
Right.
Actually, use your noggin, get in there with a meter, and check this stuff out.
You know, let me just say a couple of things. A lot of these compressor failures we talked about, the great majority of them can be prevented. All
Absolutely.
right? A lot of them can. Not all, but they can. But somebody once told me something. If you don't find out why a compressor failed and you replace it, it's going to fail
Yes.
again.
Yes.
Right? But there's also compressor maintenance that you can do. A lot of people will go do maintenance on a system, and I think the two things that we really don't check on a regular basis are the capacitors, if there are any,
Sure.
and the compressors. We don't take you go to the doctor, you get a physical once a year or whatever you do. They check everything top to bottom, right? We should be doing things too. You can take a resistance reading on a compressor as part of a maintenance just to check
Yes.
the windings. Then it'll give
Absolutely.
you some idea of what's happening, and you may find something early. Just like the same reason you get an EKG when you get to our
Yeah.
age, it may find something early before it ends up, not you, Roland, but everybody else. You have no heart. So. But, I just wanted to throw that out there. If you don't find out, if you replace a compressor and you don't know what killed the first one, the second one is likely to die.
Yes. Absolutely.
Yeah. What about bad valves at the compressor? What about damaged scroll? Where is that going to come from?
Yeah. Oil return, refrigerant slugging,
Flood back,
overheating.
Slugging, yeah. Just like you said.
And keep in mind that discharge temperature that you measure at the discharge line of the compressor,
Yep.
at the valves, it's higher.
Yes.
Of course it is.
Yeah, it's much higher, so you got to think of that temperature. That's an indication of if that temperature is too high, let's find out why.
Yes.
Right.
So at the end of the day, keep it tight, keep it clean, keep it dry.
Always.
That system will run for 20, 30 years.
Absolutely.
Follow best practices.
Do it right the
Please,
first
do it
time
right.
and be done with it.
And get rid of those old habits. If you were like me and taught by an old timer, or you're an old timer, just
Yes.
it's never too late to do it right.
Absolutely.
That's right.
Who's ready for pizza?
No, not me.
Not you.
I really want a cubano.
Well, let's go get
I
some.
want some chicharrones.
Let's go get some.
All right, guys, this has been a great episode.
Yeah,
We'll see you on the next one.
Hasta la
right.
vista.
Ciao.
I'll be back.
Adios.